Hi, I'm Jennifer Bell, and today the problem we're going to solve is food and clothing are shipped to survivors of a natural disaster. Each carton of food will feed 12 people, while each carton of clothing will help clothe 5 people. Each 20 cubic foot box of food weighs 50 pounds, and each 10 cubic foot box of clothing weighs 20 pounds. The commercial carriers transporting food and clothing are bound by the following constraints. The total weight per carrier cannot exceed 19,000 pounds. The total volume must be less than 8,000 cubic feet. How many cartons of food and clothing should be sent with each plane shipment to maximize the number of people who can be helped? To solve this, we'll be using linear programming, a method for solving problems in which a particular quantity that must be maximized or minimized is limited by other factors. We first identify the objective function is Z equals the number of people helped is 12 times the number of cartons of food plus 5 times the number of cartons of clothing. Now we need to identify the constraints. In our problem, the constraints are weight and volume. For the weight, we can write the constraint as the total weight of the food plus the total weight of clothing is less than or equal to 19,000 pounds. Since each carton of food weighs 50 pounds and each carton of clothing weighs 20 pounds, we can write the equation as 50 times, or 50x plus 20y is less than or equal to 19,000 pounds. The second constraint is volume. The constraint can be written as the total volume of food plus the total volume of clothing is less than or equal to 8,000. Since each carton of food is 20 cubic feet and each carton of clothing is 10 cubic feet, we write it as 20x plus 10y less than or equal to 8,000. To solve a linear programming problem, we need to first graph the system of inequalities representing the constraints, and second, find the value of the objective function at the corner or vertex of the graphed region. So to graph 50x plus 20y is equal 19,000, we find the x-intercept and the y-intercept. So when x equals 0, 20, y equals 19,000. So y equals 950 or 0,950. And when y equals 0, 50x equals 19,000. So x equals 380 or 380, 0. To graph that, we will do 950x and 380 for the y. Now we'll do the same for 20x plus 10y is equal to 8,000. When x equals 0, 10y equals 8,000. So y equals 800. So y equals 800, or 0, 800. And when y equals 0, 20x equals 8,000, so y equals 400, or 400, 0. We graph that with the 800 on this one and the 400 here. And we connect those. And this will be the area where we'll be looking at. To find the intersection of the two lines, we'll use the addition method. It's 50x plus 20y equals 19,000. There's no change. You do 50x plus 20y equals 19,000. And 20x plus 10y equals 8,000 times -2. We have -40x minus 20y equals -16, which brings us 10x equal to 3,000. So x equals 300. Now we can substitute 300 for x plus 20y equals 19,000. That gives us 15,000 plus 20y equals 19,000. Then we're going to minus the 15, bring 20y, minus the 15 brings 4,000. Do 20. And that brings us y equals 200. So the intersection points is the x is 300 and the y is 200. Right there. So now we're going to need the values of the corners of the vortexes. So we've got the corners, x and y, and the objective function is z equals 12x plus 5y. So for 0, for 0, 0, z equals 0. For 0, 800, z equals 5 times 800 equals 4,000. 300 and 200, z equals 12 times 300 plus 5 times 200. That's 3,600, and 1,000 equals 46,100. And the last one is 380 and 0. Z equals 12 times 380 equals to 405,560. So using the linear programming, we can maximize the number of people that can be helped by sending 300 cartons of food and 200 cartons of clothing on each plane. Thank you.